Hello everyone, this is Mrs. Lindsay, and today we're going to talk about a second use for the second derivative test. Okay, so the first derivative test, you find their critical numbers, and then you can find the intervals for which it's increasing and decreasing, as well as any relative extrema, so relative max or mins. You can also find the relative extrema, or in other words the max or min, with the second derivative test. Now we won't use this often, but I did want to talk to you and show you an example of how and or why this works. So again, the second derivative test, we typically use it for concavity, but again it can be used to find whether or not we have relative extrema. Okay, so let's take a look at the second derivative test here. If the first derivative of c equals 0 and the second derivative exists on that interval, if c, and I'm going to highlight a couple things here, if c is the second derivative of c is greater than 0, then it's a relative minimum. So kind of notice that. That's a greater than 0, then f of c is a relative minimum. If the second derivative is less than 0, then f of c is what we call the relative maximum. If the second derivative is equal to 0, then the second derivative test fails, and you will have to go back and use the first derivative test, which is what we're normally going to do to actually figure out and find the relative max and mins, or in other words, the relative extremas. So again, this is a little bit different. So typically, the first derivative finds, again, the relative max and mins. We're going to try to find that with the second derivative test on this example. Okay, so first we need to take the first derivative, and we're going to use that to find our critical numbers. So first derivative, and then to find the critical numbers, we set that equal to 0, and then use our algebra skills to find the solutions to x here. So in this case we'll factor by taking out a GCF, and then we set each portion equal to 0. So we find our critical numbers to be 0 and 3. So again, normally we actually will then make a number line and check our open intervals, but now we're going to use a second derivative test to figure out max and min. So second derivative, so the second derivative here would be 12x squared minus 24x, and then we take these critical numbers of 0 and 3 and we will substitute those into our second derivative. So if I plug in 0 first, if I plug that in, I'd get 0 minus 0, so that gives me 0. And then if I plug in 3, here I will get 3 squared, 9 times 12, subtract 24 times 3, and that should give me 36. So what we care about with this is, going back to our guidelines here, our rules, what happens? Well, in our first case, we got it to be 0. So in other words, this test fails. So here's where we still just have to go back to our first derivative. So the second derivative test fails. So we're going to go ahead and go back and we'll test on our number line 0. So if we plug in, again, using the first derivative, something below 0, that's supposed to be a negative 1 there, and something above it, if we plug in negative 1 here, if we plug in positive 1, you will see in this case that we get both negative numbers. So in other words, there's no relative max or min, so in other words, no relative extrema at x equals 0. So let's go ahead and then come back to this case here with the 3. This case, it was positive. So again, it was greater than 0. So let's go back to our guidelines here. And in this case, it was greater than 0, so that means we have a relative minimum at that x value of 3. So when we have, this is a relative minimum, when x is 3, And again, to always find the y value, you want to plug it into, hopefully you're saying, Mrs. Lindsay, you want to plug it into the original function, always, this original function here. So it would be 3 to the 4th minus 4 times 3 to the 3rd plus 1. And we do our calculations on that. We should get that to be negative 26. And that is our relative minimum. So we can use our second derivative test to help us find the relative extrema. Now typically we're going to do this all with the first derivative test. We'll find the increasing and decreasing intervals, and then the second derivative test we'll use for concavity, but this is just another option that you can use to determine the relative extrema. So just to kind of recap here just a little bit, why does this second derivative test work? Because we have found a critical number and we have a potential max or min. So if the second derivative is greater than 0 from previous, we know it's concave up. And then the critical number must be kind of situated like that, right there on that horizontal tangent. If the second derivative is less than 0, then it is concave down. And therefore, the critical number must be situated like this on our horizontal tangent. And if the second derivative equals 0, the critical number might not be a max or min, and we should check the first derivative test. Okay. So this concludes the second day of the second derivative test.